Alright guys, in this video we're looking at similar figures, okay, and similar to the congruency test where you are to state the case of why two figures are congruent through a series of facts, we're going to do the same thing with similar figures, okay, focusing on triangles. And the one thing that sets apart from congruent and similar figures is that similar figures looks the same, but it's a different size. Okay, so you could have a smaller triangle with a bigger triangle, but they are similar to each other. Just one is shrunk and one is blown up. Okay, whereas congruency, two congruent figures, they are exactly the same in every shape and form. So I'm going to go through the 4 different tests to prove similar figures. And the first one is going to be angle, angle, and angle. So if I were to, let's see, I'll make it a square there. So a square there, a cross, and a dot. So we'll go A, B, C, D, E, and F. Okay, one thing that you need to know is that no matter how big or small triangles are, if they are similar, all corresponding angles will be the same. Okay, and so the first thing is the statement will be, I guess, triple A. Okay, and triangle ABC is similar, so that's our symbol for similar to triangle D, E, F. And remember the sequence and the order of vertices. If we're going to start with A, we're going to correspond it to D. If we then move to B, we need to move to E, and then finish off with C, we need to finish off with F. Okay? So we could say that angle A is equal to angle D, angle B is equal to angle E, and then angle C is equal to angle F. Okay, so that's fairly simple when it comes to angles. The next one will be, let's go triple S. Okay, so let's say we have again A, B, C, D, E, F, but we've got 6, 7, and 10, and then 9, 10.5, and 15. Okay, so if we're looking at the sides, there are no angles that are noted in this example. So we're going to choose triple S. The scale factor here is really important. Okay, so let's look at 6 and 9. Okay, so remember the scale factor is your image divided by the original, the object, which is 9 divided by 6, and that's 1.5. Now, in order for this triangle on the right to be similar to the triangle on the left, is that the scale factor for each of the sides have to be the same. The moment that one of the sides do not have the same scale factor, then is no longer similar. Okay, so let's have a look at this. So 10.5 should correspond to 7. 10.5 divided by 7 is 1.5 as well. So they are the same. And now we're looking at the third one. So we're looking at 15 and 10. So if we got 15 divided by 10, that is also 1.5. So all 3 sides have the same scale factor of 1.5. So we can comfortably say that triangle ABC is similar to triangle DEF because AB and DE, the scale factor is 1.5. The scale factor of BC and EF is 1.5, and the scale factor of AC and DF is also 1.5. Okay, so sorry that was a little bit squishy, but hopefully that helps you understand that we're looking at scale factor here. Okay, so let's move on to the next one here. We've got a triangle, two triangles again, and we're going to be looking at SAS. Okay, so side, angle, and a side. So A, B, C, D, E, F, and we've got 6, and I'll put a dot as the angle, and then 10, and then 9, and a dot, and then 15. Okay, so the idea here is that with all of these things, you have 3 cases to prove, and as long as you have at least 3 pieces of information that are supportive, then they are similar figures. So triangle ABC is similar to triangle DEF, and the way that I'm writing it out for you in this video is the way that I want you to be writing it in your answers. Okay, so here we have let's say looking at AB and DE, because those two sides correspond with each other. 9 divided by 6 is 1.5, and then AC and DF, we have 15 divided by 10, which is 1.5. So they have a scale factor of 1.5, which is the same, and we have an angle which is also the same. So the first statement, or your first factual statement, is that angle A is equal to angle D. And then you would also say that the scale factor of AB and DE is 1.5. The scale factor of AC and DF is 1.5. Okay, great. And we'll move on to the last one, where we're looking at RHS. So we're looking at the right angle, the hypotenuse, and the side. So we've got ABC, DEF, and we've got a right angle here. The hypotenuse, we'll look at 6 and 12, and say 5 and 10 over here. Okay, so it's very similar to SAS, but in the context of a right angled triangle. Okay, so triangle ABC is similar to triangle DEF. That's what we're trying to prove here. And automatically we can say that angle A and angle D is 90 degrees. Okay, both the same. So A and D are equal. When we look at the corresponding sides, we know that 12 divided by 6 is 2, and 10 divided by 5 is also 2. So that means the scale factor is 2. So the next statement we could say is that side AC and DF has a scale factor, so scale factor of AC and DF is equal to 2. And then the last statement, we could say that the scale factor of BC and EF is also 2. Okay, so there's our 3 points of proof to support that statement that the two triangles are similar to each other. And it's really important that you look at the information that is provided to then choose whether you're going to have AAA, SSS, SAS, or RHS. Great. If you've got any questions, let me know. Otherwise, I'll see you in the next one.